costs are one of the really black arts of Amazon Web Services. And the theory is really easy. Pay for what you use. And it sounds great. And usually, to be honest, you spend less money with Amazon than standing up your own $1 million data center. Almost all the time. But it can be really, really complex. Some services charge by the number of requests you make. Some services charge by the amount of data you use. Some services charge by, there's another one, requests by the time you're running. And some by all three. With the result that this is what Amazon calls the simple cost calculator. You can go in here and you pick your services on the left and you have all the little things that contribute to the service cost in the middle. And if you know exactly how many services you're going to be using and at what level, you can come up with an estimate of your monthly bill. Yeah, we're not going to go down that path. Instead, I want to start, especially with IoT, with two ratios. If you do something once a second, you're going to be doing it 2.6 million times a month. If you do it once per minute, you divide by 60, 44,000 times per month. Pretty much everything you're going to do with IoT, from data volume, number of requests, is all going to follow this ratio. We're going to start with storage, which is a lot of people's concern. Now, when I started working in this industry, a 10 megabyte disk drive was somewhere north of $1,000. I think of storage as an expensive thing. And you look at it, and the numbers add up really quickly. Okay, so this is a sample IoT temperature sensor, just temperature. It's using long doubles, which you wouldn't do in practice probably. It's 108 bytes, really small. But if you do 1 record per second per sensor, do the 2.6 million per month, that's 271 MB per month. And like Eric, I'm going to switch to megabytes, but we're actually doing multiples of 1024, which is why things don't scale easily here. Okay, add 1,000 sensors, that's 265 gigabytes a month, or 3 terabytes a year. Seems like a lot of money, except that, S3 standard access, that's $73 a year for that. $1,000 buys a lot of S3, especially if you compress, which gives you about an 8-to-1 compression ratio for things like JSON, or use a format like Avro that gets rid of the metadata, as Eric said, and you're down to single-digit dollars per year. So don't worry about your storage. Although it's a good thing to do the examples of the ratios. Where you really should be looking is starting at the different components of your data pipeline. And we'll start with the front door. And this is a case where Amazon charges you for a lot of different things. 4.2 cents per connected device per year. For most businesses, that's not going to make a difference. For Amazon, which may have 10 million devices connecting, it's a nice source of revenue. What's going to hurt you, though, are the things below that. The messaging. Every message comes in is a millionth of a dollar. Seems cheap until you're looking at 2.6 million messages per month per sensor. A device shadow is $1.25 per million operations. And then the rules and actions. So in AWS, Don had gone through earlier, the core IoT, you have rules that select messages that then get passed off to actions, such as writing to Dynamo. You pay per million messages. So some numbers here. If you've got 1,000 sensors, once per second, you are paying $2,600 a month just for messaging costs. There are ways to get rid of that, but you'd also be paying for actions and rules. Cut that down to 1 message per second, the prices are much more ignorable for any business. And I'm speaking at business levels of service here. As an individual, I'm really happy that I've figured out how to get credits from Amazon. Go to the summits, they give you lots of credits. The middle of the pipeline, we've been talking about Kinesis Streams, Kinesis Firehose. And Kinesis Streams are, in my opinion, one of the deals of Amazon. They're charged per hour and per request, but if you figure out the total number of requests, it costs 50 cents a day per shard. Or if you want the extended retention, more than 24 hours, 75 cents a day. Now that can still add up. I was working on a project a few years ago where we estimated we would need 5,000 shards, which turns into $56,000 a month. We ended up going with Kafka rather than Kinesis and brought up a Kafka cluster for I think about 4,000, 4,500 a month. Kinesis Firehose, which you're going to use to batch up your records, is based on the gigabytes ingested. And it's calculated where it rounds up each record to the 5 kilobyte minimum amount. So that 108 bytes of IoT data is really 5 kilobytes. And you divide that out. It adds up. And again, this is a case where if you're doing 1,000 sensors at 1 message per second, 365 a month. Not that bad. But again, if you can cut it down to 1 message a minute, it's insignificant. So far I've been talking about things that don't cost a lot. Oh, sorry, one more thing that doesn't cost that much is transformation if you use Kinesis Analytics. So for example, getting the rolling average. They figured out based on a KPU hour, Kinesis Processing Unit hour, which doesn't really tie to anything like an EC2 instance hour. But basically, if you're doing a SQL transform with relatively low volume, and again, the volume is about that 1 message per second, no problem. You're going to use 1 KPU, which is $80 a month. Where things start getting expensive is when you start doing things like Lambda invocations, okay? And again, this is one of the reasons I like Kinesis, is you can invoke Lambda directly off IoT Core. Every message comes in, invokes a Lambda. With Lambda, you pay for the number of invocations and the execution time rounded up to 100 millisecond increment. At our messages per second, you're looking at about $1,100 a month to run Lambda directly off of IoT Core. Now again, you can cut that significantly down to $20 a month if I do my math, 200, 20 I guess, if you do it per minute instead of per second. Or you can attach your Lambda onto your Kinesis stream and tell your Kinesis stream to invoke the Lambda after every minute or every 100 or 1,000 messages. And the price will depend on how much you invoke it, but again, it's going to be much, much shorter. And you won't, since Kinesis rounds up execution time, 1 message might take you 5 milliseconds to process, rounded up to 100 milliseconds. 100 messages is 500 milliseconds. So this can start to hurt you if you're driving things directly off IoT Core. Analysis is where you start spending the big money. And there are a lot of different analysis platforms. I just picked out 3 because they're kind of different trade-offs. So Redshift is Amazon's decision support database. It's based on Postgres, so the Postgres query engine, and a parallel storage engine. So when you're dealing with things like 100 million rows of data that you need to scan, it divides that up between 4, 8, 16, however many nodes you want to put in your cluster so that each individual node only scans a fraction of the data. It's perfectly parallelizable. It's useful for ad hoc queries, especially things that involve joins because it's a relational database, and especially things where you might be running a dashboard and want to get like 3 stats for your users and not wait a long time to compute it. Cost is going to depend on your node type. But a basic small Redshift cluster is going to cost you a little over $700 a month. It's about $1 a day. And you can do things to reduce that cost, such as buying reserved instances, which I think takes it down to about $500 a month. But it's going to be there, it's going to be running all the time, and you have to manage the data going into and out of it. By comparison, Athena is Amazon's SQL tool for working with data lakes. And it basically, I think it's actually Spark under the covers. You write SQL queries, it reads in the files, parses the files, and executes the SQL queries on the files. It's good for ad hoc queries when you're experimenting, trying to understand your data. Less good for things like populating a dashboard. A query that might take half a second on Redshift is going to take 10 seconds on Athena. And it's also great for data transformation. You could get JSON data coming in and you want to turn it into Avro. It's a really simple select star output format Avro in Athena, and now you can process that and just run through all your data and convert it. You pay $5 per terabyte scanned. Okay, so that 3 terabytes earlier, right, you're going to scan that whole thing to run a query over your 3 terabytes in a year, that's $15. Of course, if you gzip it, they don't charge you on the raw data, they charge you on the actual data that they've read. So really, you're looking at about $3 to run the query. You can run a lot of queries at $3 a query and not hit $700 a month. So if you're running ad hoc queries, it might be very worthwhile to use something like Athena. On the other hand, if you're running dozens of queries a day, you might very easily run into a multi-$1,000 bill each month. So again, it's a trade-off. And lastly, I use Spark on EMR. Eric talked about Flink, which is accepting streaming data in. I'm thinking of Spark as reading the files that you've already got. And again, machine learning, really large-scale production data analysis. You can also use it for ad hoc queries hooked up to something like PySpark in a Jupyter notebook. And like Redshift, you're bringing up actual physical EC2 nodes. And the cost is going to depend on the type of nodes you're bringing up, how many. I figured it out at a relatively small 16-node cluster. You might be spending about $5 an hour. That's about 40 cents per hour for the machines. The key there, though, is let's say you're doing a nightly data analysis run. You might run that cluster for 2 hours and then shut it down, and you don't pay for it the rest of the time. So the key thing is you have trade-offs. Going with one specific type of data analysis, it's going to be your biggest cost, probably. Going with one specific approach, think of the trade-offs. And lastly, for cost components, I want to talk about data transfer. So what we have here is kind of your standard web app deployment structure. You have compute engines, and this should be a database, except I was kind of lazy with my icons. They're running in private subnets. For a web app, that's exactly what you want to do. It protects traffic. It doesn't let people get access to those machines. You have in a public subnet a NAT gateway. So that these machines in the private subnet, and this is getting into the VPC stuff, can actually talk to the internet, which they might need to talk to S3, except hold on a minute. And because you're using Jupyter Notebook on your PC, you're pulling stuff down directly from S3 to your PC. Data analysis, this is a really bad idea because of data transfer charges. Okay? Over the NAT, you're spending 4.5 cents per gigabyte for data that moves over the NAT in any direction. Doesn't seem like much. I once was moving people into a VPC and discovered after a week and $600, which was pretty cheap, that, oh yeah, we move 2 terabytes a day over the network from our third-party suppliers. It does add up really quickly. Friend of mine is working for a company that does data transformation and was trying to figure out ways of changing their communications within their VPC because they were spending $15,000 a month on their NATs, and figured that if he could get just certain percentage of traffic moving, not going through the NAT, is going to save significant dollars. Also, a lot of people with NATs use one because it also costs 4.5 cents an hour and you want to save that cost. But what you're not noticing is if you're using one, you're also doing cross-zone, cross-availability zone charges at a penny a gigabyte. Again, seems small, $10 a terabyte, $30 for your 3 terabytes of data. And when you have these machines talking to each other, again, this is probably more likely a database, you're also spending a penny a gigabyte. And the big cost here is 9 cents a gigabyte for data moving directly from S3 to your PC. Now, there are a lot of ways to resolve this, okay? And the next slide is going to talk about this a little bit, but I'll just hit them here. Putting your compute in a private subnet may not be the way to go. If you're in publicly, EC2 downloading from S3 is free. Maybe you need to be in a private subnet for whatever reason. Well, in that case, don't use your NAT, you can use a VPC endpoint. And again, free. Data from S3 through a VPC endpoint into your VPC is free. Other VPC endpoints charge you a penny a gigabyte, which is still, it adds up, but it's not the 5.5 cents of running over a NAT gateway. And that's kind of the key point, is architecture will be different when you're doing IoT and data analysis versus doing a website deployment. And you kind of have to think about it. The biggest thing, reduce your message frequency if you can. Really, to be honest, temperature readings every minute is too frequently. Temperature isn't going to change that often. Every 10 minutes, every hour. That, as I said, will percolate all the way through on all other charges. IoT specific, Amazon offers this feature called direct ingest, which your devices say, I'm going to this rule, and the messaging charges disappear. You still have to pay a rule and action charge, but the messaging charges out of that are 60%. Aggregate and compress your data before you upload it to S3. Again, it costs less to use Athena, costs less to move it, costs less to storage. VPC endpoints, which again is getting into network architecture, and probably most important for data analysis, don't move your data across a NAT. I'm going to wrap up with your new best friend, and a lot of people don't know this exists. AWS in your billing console will tell you your charges for the month, your estimated charges for the month and your charges for the previous couple of months. You also have the Cost Explorer, which is, it's up in the left nav, which lets you drill down and start adding filters. So I'm filtering, this diagram is filtered from a specific account, the account that we were using to develop the workshop for this event. And you can see in July of this year, we really didn't do much working on the workshop. By August, we had brought up a Kinesis stream. By September, Kinesis stream, Kinesis Analytics, and up at the very top there, you can see a little bit of the IoT gateway running. It's really nice to be able to drill down and to see, okay, our charges went up each month, and this is how it broke down. I've also found it, not to shame one of my coworkers, but just looking through the data for our overall accounts, I found a SageMaker instance that had been running. You don't need to raise your hand, Ken. I found a SageMaker instance that had been running through the month of September. Okay, not huge money, $150, but it was an accident, leaving it up. Finding this out is really easy with Cost Explorer. It's like, hey, who's running the SageMaker loads? And of course, I look at Eric first. He's our analysis person, but it wasn't him. Another feature with this is you'll notice that I'm filtering by a single account. As Steve said earlier, separate accounts are the greatest thing to use with Amazon, and have made them really easy. In fact, for the workshop earlier this week, I spun up 40 new accounts for the workshop so that we could just let people use accounts without using their own accounts. But you want to track that, and you want to keep loads dedicated to an account. You don't want your development loads, your development costs, to be mixed in with your production costs. Understand your production costs, use your development costs to figure out what you might be spending in production, but actually track them separately. And definitely pay attention to the costs. That's probably the most important thing of this talk, is you can't go in upfront and know your costs. You really can't, because there's so many components that goes into it. But pay attention along the way and use the tools that Amazon gives you to track and really forecasting for budgets to understand when your costs are going up. And that is it. All right.